Let's start. So, good time. Okay, let's start. Challenge and innovative approaches to VM and Baremetal integration in OpenStack is the title. And my name is Yushiro, and joining LY Corporation as a senior software engineer. And I used to be a core reviewer in firewalls as a service in Neutron and vendor plugin for ML2 plugin for the Neutron and contributing some ironic multi-tenant isolation, something like that. And recent my hobby is a Rubik Cube, and the best time is 40 seconds, but today, fail. Okay, sorry. And he's Mitsuhiro, and he also joining the LY Corporation as a senior software engineer, and he used to be a contributor in OpenStack Cinder and Kubernetes, Single Storage, and now he's focusing on the hyperscale OpenStack cloud environments. So this is the topics to talk about. In short, we'd like to share about the Baremetal as a service in our private cloud based on OpenStack. So first, background and vision. So about us, as an LY Corporation is formed by company merger for the X Line Corporation and X Yahoo Japan Corporation. And after company merger, we started to develop a new private cloud called Flava. This is totally based on the OpenStack, one single OpenStack cluster. So the point is that name is Flava and based on huge scale, huge single OpenStack cluster. And we are previously using the two private clouds. And we provided not only virtual machine but also like physical machine as an instance for end users. So do you know why Baremetal is required or some demand? Imagine that, and the answer is here. So this is, of course, this is from our point of view, the growing demand for the Baremetal as a service. And you know, AI, machine learning, easy to understand. So they are like direct GPU and hardware and provisioning to attached to the physical machine, and they like to use for AI or machine learning. And the other one is a legacy system migration and storage workload. And last thing is software with CPU core based license. These are like current demand for why Baremetal is required. And our vision is a Baremetal that feel like VM. So this is first. So in order to achieve our vision, so we determine the 4 points. And the first one is easy to understand, so it's unified API. So this is the respect for the ironic. So like one API endpoint for both VM and physical machines. And reusing internal provisioning tools. So like of course, like after company merger, we already have some like internal in-house provisioning tool or IPM manager or something. So we should reuse these parts in our new private cloud. And the third point is a fully automated and provisioning in minutes, not weeks. And they completing all necessary registration in one API. So for example, like once you created the Baremetal server or virtual instance, some company has an asset management tool, right? And like one instance creation, and that triggers like asset automatically register the asset management system, something like that. And the last one is integrated networking. So we also provide some neutron network and subnet feature. So of course the Baremetal server can use these network feature, same as a VM. So of course we really wanted to use ironic. However, so existing system, we already have an internal provisioning tool. So we just decided and adopted a pluggable architecture of Novar's BART driver for Baremetal instead of Ironic, and support some functionality with VM as much as possible in power control, network, and asset management. So this is the Flower Baremetal system overview, the second section. This is a high-level architecture and core plugin. So the top of the things are end user, and sorry, I excluded the dashboard. So like please imagine that the user has a dashboard, and this is a Nova's component, OpenStack components, and this is a custom components I marked as a blue. And interesting point is a notification handler. So like just consuming the keep on consuming the RabbitMQ and trigger something via getting some event from the OpenStack side. And I will explain it later. And the VPC agent here, in the Baremetal server side, there are two important agents, Flower PM agent and VPC agent. But due to today's presentation, it's only 30 minutes, so let me focus on the VPC agent today. And this is the in-house existing components. So yeah, let's dive into the implementation part. And let me explain from top to bottom for each part. So first of all, the seamless user experience. I think it's very easy to understand to show some dashboard for in creating the physical machine. And okay, let's go. And this is the creation workflow. So right side you can see the dashboard for our Flower product. And first, end user can specify virtual machine or physical machine, and select the physical machine, and selecting the name. And after that, specifying the availability zone and HA group. Please imagine that this is a server group in Novar's feature, like hardware distribution, isolation feature, and like user script. And finally, press the launch button. Like one API is called to Nova to host servers. So this is totally equal to this CLI, so OpenStack server create, and then with flavors, with network, and some additional parameters. This one. And second, this is a unified network with the VPC. So inside, after the Baremetal server is booted, some configuration is required inside in the Baremetal server's OS. And especially this is VPC agent doing some network feature. And the PM instances are connected to our existing VPC network, another separate physical network. I'm calling that this a VPC network, but please imagine that this is totally equal to the neutral network and neutral subnet. And a VPC agent runs on the instance to enforce network isolation. So, simply inside in the VPC agent, after booting, set up some NF tables inside in the OS, and then configure some ACL situation, ACL configuration. So, and this is our internal specification. So if we create one network for the virtual machine and physical machine, our internal specification, we should split the subnet itself for this subnet is for VMs and this subnet is for the PMs and not mixture. So that how to prevent users from placing PMs on VMs IP branches and vice versa. And the simple solution is powerful tagging mechanism in Neutron. So that in case of the subnet for Baremetal servers, the one tag is added, the VPC agent equals true. So if this tag is added, the VMs cannot be created on subnet with this tag. And the tag is immutable and can only be applied to empty subnets. So by doing this tag mechanism, this guarantees the network isolation at the API level. And from now on, Mitsuhiro will explain about how to more detailed parameters in creating the Baremetal server.
Okay, thank you, Furukawa-san. So from now, let me explain more detail about our Baremetal mechanism. So first one is the request parameter in creating PM. So we allow user to specify the hardware profiles in order to create the new Baremetal server. So let me explain more detail. So this is the hardware profile. So as you know, the single PM server can have the multiple disk configuration. So let's say RAID 1 or RAID 0 or RAID 1 or RAID 5. So based on the end user demand, they would like to create the RAID in order to during the new instance creation. So we consider how to provide that situation. And one easy way is we provide multiple flavors per RAID configuration. However, if we provide multiple flavors for each RAID configuration, the number of the flavor will be become so many, and it is hard to manage the flavor. So we consider another way to provide how to utilize the RAID profile by end user easily. And the solution was that this one. We define we allow user to specify the property RAID underbar profile equal RAID 1 to disk. So this, if you use end user specify this RAID profile during the instance creation, the new Baremetal instance is going to be the RAID 1 configuration. And in order to use end user demand, if end user need to consider the high performance, they can utilize the RAID 1, or if they have interested in for the more fault tolerance for the RAID configuration or server, they can choose RAID 5 with kind of the 8 disk or something like that. So this is a mandatory property, and it is a must specify the RAID profile when they create the new Baremetal instance. This is a sample of the CLI. And also they can choose the RAID configuration from the Furukawa dashboard. It's shown in the red box on the right side. So in order to provide this kind of the RAID configuration on the dashboard, we decided to store the RAID configuration in the flavor exospec metadata. So as you can see, there are two types of the RAID configuration. This is RAID 1, or second one is RAID 5. So the dashboard shows the RAID configuration by checking the flavor. Then end user can choose RAID level based on their demand. So end user can easily choose RAID level based on the demand during the new instance creation. And next, I'd like to explain about the integration with internal services, as Yushiro mentioned. On the right side blue box, so on top of the box, so there is a RabbitMQ, and we developed the notification handler which consumes the notification event from the Nova or Neutron or such kind of the OpenStack component. Then, based on the notification event, it tries to access to the internal service, company internal service like the AssetDB or Mountain service or etc. Okay, so let me explain more detail. So we are supporting the notification-driven automation flow for the new instance creation from the top to the end. So the new instance creation started from the when user make API call or run the OpenStack server create command, and that request go to the Nova API first. And gradually the Nova scheduler or Nova conductor select the destination of the target Nova compute. Then actual API requests go to the Nova compute. And yeah, that is step one. So the user runs the OpenStack server create command. Then, so the step two, Nova emits the instance update notification on RabbitMQ. So the Nova compute make a notification to the RabbitMQ. So yeah, this is the current situation. Now the instance create started, and Nova tried to update the instance information to the database. Such kind of the notification is sent to the RabbitMQ. Then anyone can fetch that notification. For our case, we developed the notification handler. So once the notification update is sent to the notification handler, so notification handler start to handle it. So this is the first event, first step to start the communicate with the other company external service like the Asset DB or OS installer or IPM manager. Then on the step 3, so notification handler service consumes the event. Let's say so the notification handler service receives the instance update. Okay, so then now time to register the instance information to the internal Asset DB as a new instance creation. And after step 3, so on the step 4, the notification handler sends the external event call back to the Nova. Then Nova computer actually, until then, Nova computer waits the Asset DB registration, and once the Asset DB registration completed, Nova receives the external event back to the from the notification handler to Nova compute. Then okay, Nova compute understand the instance is already registered to the Asset DB, so Nova computer can continue the instance creation at this moment. And step 5, so Nova compute. Now the Nova computer try to start the actual spawn method, which try to create the instance. And instance creation means Nova computer start to trigger the OS installation and the IPM or PXE boot. So that's the actual PM server start to the PXE boot, then OS server fetch the OS information from the OS installer, then gradually the OS installs ongoing. And the step 7, so during the OS installation, normally it takes, let's say, 10 minutes or 15 minutes because it's a simple OS installation to the create new hard disk. So during that OS installation phase, the Nova compute periodically check to the OS installer and ask, hey, what is the current situation? So is this OS installation phase or is already OS installation is completed, but checking the boot phase sequence or something like that. And Nova compute keep waiting until the OS installation completed or boot, first boot completed, or actually the physical server can respond the pin check or not. That is the Nova compute keep happening on the Nova compute side. And once Nova compute gets the information of the OS installation completed from the OS installer, finally Nova compute sends the instance create end notification. This is the normal Nova compute notification sent to it happened when the complete OS installation completed. Now the instance is active status. And then the instance creation is completed, and finally end user can use the active PM instance at this moment. So this is the whole of the instance creation mechanism. So we are using the we are using the notification event in order to communicate between the OpenStack cluster and our internal Asset DB based on the design of the OpenStack strategy. Okay, so now let's move on to the stock management for the PM. So as you can imagine, so the physical machine is very expensive. So unlike the VM, we need to manage the stock of the physical machine in order to provide it to the end user. So in order to manage the PM stock, physical machine stock life cycle, we designed that cycle by using the mobile, depends on the mobile and placement services. So let me dive into how we implemented it. So the diagram shown in the right side is whole life cycle of the stock management. On the top of the right top, so there is a project. So all of the project at first, the project doesn't have any Baremetal stock, and that is the first step. But in order to, based on their demand, they try to make a stock request for IaaS operator side. So they make workflow. Hey, please allow us to use the Baremetal. So based on that demand, so we allow to project to use the Baremetal server. And now that after that, the Baremetal project becomes the Baremetal Allowed project. Then now this project enters a cycle, so they can make a stock request, or they can, once the stock request is approved, they can create a new Baremetal instance. Or finally, at step 3, so if they no longer need the stock on that project due to termination of the project or something like that, they can return the request. So this kind of the whole stock life cycle we implemented based on the Nova or placement APIs, so based on the OpenStack design. So let me explain one by one more detail by with showing our dashboard. So this is the dashboard view when the end user make or request stock. So sorry for the very small character, but in this stock request workflow, end user can make a request by specifying the flavor, like this flavor is 20 CPU or 64 gigabyte memory or 480 gigabyte storage. And they can specify the required availability zone. So currently we are supporting the 3 availability zone in order to provide the high reliability for the application. So they can choose based on their demand for the exit. And finally, they can put the number of the quantity for the servers per exit. And once this request is approved, they can get the actual Baremetal server. So the right side figure shows the current stock situation with the end user project. So as you can see on the top flavor, the 20 CPU flavor, the project have totally 11 stock, and currently 1 server is used, so the remaining available server is 10. So based on their demand, the stock is assigned to the project once the operator approves it. So what the important point is that the end user can easily understand which flavor type they can have available servers, or where is the location of the server they can understand by checking this UI. So easily they can design how their application need to work by their demand. And this is the last part. This is a creator instance similar to Yushiro shared in previous. So once the project gets a stock, now they can create the instance using the Furukawa dashboard by specifying the instance name or using the VPC or availability zone or something like that. And this is the final phase. So finally, if they do not need to keep the stock no longer, so they can easily return their PM stock by using the dashboard. So the dashboard only shows the available PM server name, which means this server doesn't have the actual OpenStack instance. So PM is there, but the instance doesn't exist, so it is okay to return. And once they make a request, the PM server come back to the common inventory, company Baremetal server inventory, and they do not need to in charge. They charge that for the project. This is the whole stock mechanism we are currently providing. So end user can easily make a request, or end user once the stock request is approved, they can create, then they can return stock anytime. Okay, so from now on, I'd like to share the challenge and lesson learned during the development of the Baremetal services on new Furukawa environment. So we did a large-scale test when we prepare the new Baremetal services on our Furukawa environment. So the important point for our test case is that we'd like to know how many server creation is okay for our new Furukawa environment at once. So we gradually increase the number of the PM servers step by step. So Actually, we started from the 50 instances and move on to the 100 instances. And finally, we try to create the 500 instances at once by using the one API, Nova instance, Nova server, OpenStack server creation. So let me explain one by one from the 50 instances. So at first, so we try to create the 50 instances at once. However, as you can see, 100% failure due to the load balancer timeout. So after investigation of the root cause, so the Nova scheduler, between the Nova scheduler and the Nova conductor, so there is a select destination in order to choose the actual target server, target Nova compute, and it took about 70 seconds. However, our LB timeout, default timeout was 60 seconds, so due to this timeout, so all of the instance creation, 50 instance creation hits timeout. So in this case, so we can easily configure, extend the timeout. So we extended the timeout from the 60 seconds to 1,800 seconds. This is based on the artificial timeout duration. And after that, the instance creation for the 50 instances successfully, 100 successfully completed. And after that, we moved on to the 100 instances creation. At that time, still the success rate was good, so we tried the three attempts for the 100 instance creation, and the success rate was between the 96 to the 99, so yeah, average was around the 97 or 8. Yeah, that was good. So yeah, we understand around the 50 or 100 is okay, so we can allow user to create this level of the instance creation at once by using the UI or by using the OpenStack CLI. However, the next trial, so we tried to create 500 instances but at once. And as a result, so as you can see, the 41% instance creation was failed. And this time, so actually the root cause was reset, control plane service saturation. So we are using the Kubernetes service for hosting the Nova API or Nova, all of the OpenStack service, Nova, Neutron, Grants, and such kind of C plane services were saturated by getting this kind of the huge instance creation request. So we break down the errors like this. So we observe the keystone error happened on about 79 cases of a Newton server error, especially for the new port creation for the instance. It's 124 error cases, or other errors like the placement, Baremetal driver timeout, or asset DB error, or install error. So there are so many parts of the errors happens. This kind of the huge instance creation. So yeah, we understand around the instance creation, it is better to keep around the 100 instance at once. It's better for our current cloud situation. But gradually, so we need to consider extend the instance creation, less instance creation number in order to allow to the end user more easily to use the Baremetal services. Okay, so let me wrap up our session. So our achievements, so we provide we bridge the gap between the VM and PM. So we provide the unified APIs. It's allow to user to operate the VM and the PM. It's very same operation. And also we provide the fully automated provisioning and asset management cycle based on using the notification event. And also we support the very simplified stock management through mechanism through UI, so end user can easily make a request for the stock or easily return the stock based on the UI operation. And for the key takeaway parts, so user experience is important. So aligning operation for different resource types, simplify adoption and automation. And we designed the event-driven notification architecture, so which is aligned to the current OpenStack mechanism. So we do not heavily modify the OpenStack itself, but we just develop the event handler application, and that handler application can do everything based on the OpenStack notification event, like the instance create start or instance create end or something like that. And finally, yeah, we the same thing, but we extend the OpenStack mechanism, and we do not replace so many OpenStack things. So based on the OpenStack functionality, we developed our new event handler, which handles the OpenStack real-time services. Yeah, that's all for our today's presentation. Yeah, thank you for attention. Yeah, someone have a question? Yeah, please.